So the question goes like this: a block with mass m 2 kg, so this is the mass m, and this one is 2 kg, is placed against a spring on a frictionless incline with an angle of 30 degrees. So this incline's angle is 30 degree, and the mass is placed against a spring, and here the spring has a spring constant of 19.6 Newton per centimeter, and it is compressed 20 centimeters. So it goes 20 centimeter and then released. So the block goes in this direction and the spring is compressed 20 centimeter. So the question what we need to, the answers what we need to find, we need to find are what is the elastic potential energy of the compressed spring. So the way when the spring is compressed, how much its potential energy. And second one is how far along the incline is the highest point from the release point. So how far basically the block goes. So once the block is released, this mass is released, it will go in that direction because of the potential energy that it gets from, because of the kinetic energy that it gets from the spring's potential energy. It will go upwards. And how far will it go? So let's first find what is the spring's potential, elastic potential energy. That will be half k x square, and k is here 19.6 Newton per centimeter. So what I will do, I will convert that into meter, Newton per Newton per meter basically I want to convert it, so like that. And then here this one goes up to 20 centimeter. So 20 centimeter is 0.2 meter, so that one square, because half k x square. The compression is 20 centimeter, which is 0.2 meter. That one, that is x. That one squared times its spring's coefficient, which is spring constant basically, which is 19.6 centimeter Newton per centimeter. That is 19.6 into 100 Newton per meter. So let's see how much is that. So that is 39.2 joules. That is the energy, the potential energy. Now when the spring is released, this potential energy is transferred into the mass as kinetic energy, the block as kinetic energy, and with that kinetic energy it will have a velocity there, and with that energy it will go upwards, and it will stop ultimately because it is going uphill against a inclined slope. So the potential, the kinetic energy that it has, so the velocity, if we want to find what is the velocity of this when it starts moving upwards, will be the spring's potential energy will be given to the mass as kinetic energy. So that will be half mv square, and this v will be the initial v. This v will keep decreasing as it moves upward in the inclined slope. So this is the initial v when full of spring's potential is given to the block as kinetic energy. So v square will be, we can get rid of the half here, so that will be kx square divided by m. So kx square divided by m, or what I could do, I could have just written this 139.2. so basically I will I don't know, I will erase this part. This one I will leave like that. So this is half mv square, so that will be 2 and m times 39.2. so m is 2, the mass of the block is 2 kg, so this is 39.2 basically, and v is square root of that, 39.2 square root, which is 6.26 meter per second. So that is the velocity, initial velocity. Now we need to know how far does it go in that direction, upwards, upward the hill. So that equation will be v square will be u square minus 2gh. U square is the initial velocity and v square is the final velocity. Now actually u will be this much, because this is the velocity with which it's starting. Here we have a negative sign because that one is, I will write g prime. I will tell why now soon. In a minute I will tell why. But u is the initial velocity, and there's the negative sign is because there is a deceleration. It is going uphill of in the inclined slope. So the final velocity, if we want to find how far it goes, that means when it stops, that is the velocity. After that it will keep coming down because of its height, basically because of the potential energy it gained after that, but we won't go there. So how far it goes is when it stops, that is the that h will correspond to the the how far it goes, basically. So h is not height in this case, though. I should remind that this one is just this distance, because we are not, this is not going upwards and we are considering it. So what we will have to adjust here is the g is, I have written g prime, so that will be component of g in this direction will be g sine theta. So g prime will be equal to g sine theta, sine theta. So here theta is 30 degree, but if theta was 90 degree, if it was coming, it was just free fall downwards, or a fall just downwards perpendicular in perpendicular direction, then it would be just g, because sine 90 degree would be 1. But here it's in an inclined slope, so the g component of g is g sine theta. So that's what we have to adjust here. Final velocity is 0, initial is 6.26, and this is square minus 2g sine theta times h. So h becomes 6.26 square divided by 2g sine theta. So sine 30 degree. Sine 30 degree is half, so 2 is cancelled. So this is 6.26 square divided by 9.8. That's approximately 4 meters. So it goes 4 meters in that direction. So once again, h is not an upward direction. It is just, I could have used another, maybe L, I do not know. So maybe in this direction it's h. So how far it goes in that direction? So all we had to adjust here is, if it were a horizontal line, if it were just a surface on a floor, then it would be just v square would be u square minus 2a x, maybe uppercase x, and that in that case it would be just in that direction. But here this is an inclined slope, so I have used the term h. Usually h is used when it's falling from a basically when it falls perpendicularly downwards. If that happens, we normally use h h designates height in that case. But here, just hope no one gets confused here. It's just in that direction. But so all we had to adjust is g. We had to write g sine theta instead of g in that equation. So basically, if it were falling from, it would be 2gh. But if g is, so that is when it is 90 degree in the surface, but if it is just falling downwards, but if it is from an inclined surface, then it is g sine theta, theta being the angle of the inclination. So yeah.